So after potentiometer, today we will discuss another important topic which is named as Wheatstone bridge. So students, all of you know this bridge is not made with sand, rod, cements, not like that. This bridge is made with 4 resistances. You see, this is our diagram for Wheatstone bridge. This is a circuit, and the main purpose of Wheatstone bridge is with the help of Wheatstone bridge we can measure unknown EMF quickly and more accurately with the help of remaining 3 resistances. You see here A, B, C and D is form a quadrilateral, and in this quadrilateral there are 4 resistances P, A to B P, B to C Q, C to D S and A to D R. So here 4 resistances, that is P, Q, R and S, and among 4 resistances we have to measure one unknown resistance. Suppose here our unknown resistance is named as S. So here we will measure unknown resistance S with the help of remaining these 3 resistances R, P and Q. Now question is how we can measure this. In case of Wheatstone bridge we use a balance condition. Is a condition which is named as balance condition. Now question is, what is balance condition? You see between B and D there is a galvanometer, and in case of galvanometer there is obviously a resistance which is named as a galvanometer resistance. Now in balance condition the no current flowing through the galvanometer, that is here Ig will be 0 for balance condition, and there is a balance condition, that means the potential difference between point D and between point B is equal. When potential difference is equal, that means there is no flow of current, because current always flows from higher potential to lower potential. So the main function of Wheatstone bridge, the definition of Wheatstone bridge, this one, write it down. It is an arrangement for 4 resistances which is used to determine one of these resistances quickly and accurately in terms of the remaining resistances. Now in balance condition, that means Ig is equal to 0. There is no flow of current between B and D. Okay, so this is our given, suppose this is our given value, and we will prove in balance condition happened when P by Q is equal to R by S. For balance condition of Wheatstone bridge, the ratio of resistance P and Q exactly equal to the ratio of resistance R and S. We will prove it. Now using this equation you can easily find out the unknown resistance. Here suppose unknown resistance is S, so you can write, so S by R, that is equal to Q by P. So from here S equal to Q by P into R. With the help of this equation you can easily find out the unknown resistance. Okay, so this is our diagram, and with the help of this diagram we can derive the condition of balance using Kirchhoff's law. So first of all, you see in between A and C there is a cell of EMF E, and current is always flowing from positive terminal of the cell to the negative terminal. So here current is flowing from positive terminal, that is I. Then this current is flowing up to point A. Now you see at point A there are two way for flowing current. So obviously this current is flowing from A to B, which is named as I1, and another current which is flowing from A to D, which is named as I2. That means here I is the summation of current I1 plus of I2, right? Okay, now A to B current flowing is I1. Now see at this point B, at point B there is also 2 direction for flowing current. So suppose for galvanometer current flowing which is named given Ig, but we will prove that for balance condition this one happens, and this one happens when Ig is equal to 0. Okay, so in general you give the name at first. So suppose at point B for galvanometer current flowing Ig, so the remaining current I1 is up to point B, then from I1, Ig is flowing through this galvanometer, so the remaining current, that is I1 minus Ig, this amount of current is flowing B to C. And now from A to D current flowing, that is I2. So up to point D current, which is named as I2. Now at point D you see there are two options for flowing current, from one, that is D to B, but always in a wire current is flowing at a particular direction. So already from B to D current is flowing, which is named as Ig. So the total amount of current I2 plus this Ig amount of current, the addition of I2 plus Ig, that is I2 plus Ig amount of current flowing D to C. So at point C you see the total amount of current, here I2 plus Ig and here I1 minus Ig, that is the summation of I1 minus Ig plus I2 plus Ig, that means plus Ig minus Ig cancel out, the total current I1 plus I2 that is entering through this cell. So the current flowing, that is I, and I is the summation of I1 plus I2, and the same amount of current is entering, that is also I1 plus I2. Now we will apply Kirchhoff's law. At first we consider the loop. Okay, consider it. Suppose we considering this loop A, B, D, A, and you just see we are considering this loop like clockwise direction. So write it down, from loop A, B, D, A, we can write. So at first you check A to B, there is a resistance which is named as P, and current is flowing I1, and your direction and the direction of current is same. So when your direction and the direction of current is same, that means negative, opposite, that means positive. I already completed this part. Okay, so here current I1 is flowing, your direction and current direction is same, so this one will be minus I1 into P. Now B to D, you see B to D current flowing Ig, and suppose here galvanometer resistance is named as G. This G is the resistance for galvanometer. Okay, so here current potential, that is G into Ig, and your direction and the direction of current is same, so this one also will be minus Ig into capital G. G is the resistance for galvanometer. Okay, now D to A, right, D to A, current direction is A to D, your direction is D to A, so this one will be plus, and resistance R, current is I2, so this one will be I2 into R, that is equal to 0. Now you consider another loop, from loop this one B, C, D, B. Okay, and same clockwise direction, so write it down, B, C, D, B. We can write, check it, B to C, current flowing I1 minus Ig, and resistance Q, your direction current direction same, so this one will be minus I1 minus Ig with multiple of resistance Q. Now C to D, your current direction and your direction is opposite, so this one will be plus, current is I2 plus Ig, and the resistance is S, and this is our unknown resistance. And from D to B, your direction and current direction is opposite, so this one will be also positive, that is plus Ig into galvanometer resistance G, that is equal to 0. So first of all you have to consider the loop, then you apply the KVL. Now you see condition, one condition given, that is balance condition, and balance condition, that means there is no flow of current through this galvanometer. So for balance condition, Ig is equal to 0. Now we will apply this condition in this equation and in this equation, apply it. Here Ig 0, so this value is 0, so from here you can write minus I1P plus I2R, that is equal to 0. So we can write I2R, that is equal to, this one will be that side, so this one will be plus I1P. Suppose this is our equation 1. Now apply same thing, that is Ig 0. So here Ig 0, that means this one minus I1 into Q, minus I1 into Q, Ig 0, so Ig into Q 0. plus I2 into S, I2 into S, Ig 0, so Ig into S 0, and here Ig 0, so this value is also 0, so this one is gives 0. That means from here you can write I2S, that is equal to I1Q. Write it down, this is equation 2, suppose. Now divide equation 1 divided by equation 2, divide it. So dividing equation 1 by equation 2, we can easily find out the condition. So equation 1, that is I1P divided by, in equation 2, this one I1Q, that is exactly equal to equation 2 I2Q, R, and here I2S. So I2 cancel out, I1 cancel out, so that is, this is our balance condition. P by Q is equal to R by S. So when there is no flow of current through this galvanometer, the condition arises when the ratio of P by Q, the ratio of resistance of these two arms, exactly equal to the ratio of R to S, that is the ratio of R and S. And here P by Q, these two arms is known as the ratio arms. Here this R is known as the standard arms, and this is our unknown arms. We will find out this unknown resistance by changing the resistance value here. This resistance is known as a standard arm. By changing the ratio of P by Q, the unknown resistance we can find out more accurately and more high order. Okay, so this is our balance condition, and you for finding balance condition we have to use Kirchhoff's law. Okay, you can say reverse process also. When P by Q is equal to R by S, in that condition the current flowing through this galvanometer, that's will be 0. Okay, now we will discuss about this topic, that is the sensitivity of Wheatstone bridge. What is the meaning of sensitivity of a Wheatstone bridge? You see, a Wheatstone bridge is said to be sensitive if it shows a large deflection in the galvanometer. Galvanometer shows the deflection when small amount of current is flowing. So when galvanometer shows large deflection for a small change of resistance in the resistance arms, this Wheatstone bridge is named as more sensitive, in which the deflection of galvanometer will be more for small change of resistance in the resistance arms. So the sensitivity of Wheatstone bridge depends on two factors. Factor point number 1, the sensitivity of Wheatstone bridge depends on the magnitude of the ratio of these resistances. The magnitude of the ratio of these resistances, the sensitivity of Wheatstone bridge changes. The sensitivity of Wheatstone bridge will be more perfect, more accurate, more sensitive when this condition happens, that is P by Q is equal to R by S. So this is our point 1. By changing the magnitude of resistances, we can change the sensitivity of Wheatstone bridge. And point number 2, that is by interchanging the cell and galvanometer, the battery and galvanometer. By interchanging battery and galvanometer, we can also change the sensitivity of this Wheatstone bridge. Now what is the advantage of uses of this Wheatstone bridge? First advantage, that is null method. As this is based on the null method, that means there is no deflection of galvanometer, so the resistance of this cell, the internal resistance of this cell, and as well as the resistance of this galvanometer doesn't affect to this null method. And second point is that is as there is no involvement of current and potential difference, so for measuring the resistances for the resistance of ammeter and galvanometer doesn't affect for the measurement. Okay, and the third one, that is we can find out unknown resistance more accurately and very high order by changing the ratio of these ratio arms, that is P by Q. So these are the advantage over other method using for finding unknown resistance using Wheatstone bridge. Now we will solve some numericals related to Wheatstone bridge. Let's see. So our problem 1, see, calculate the current drawn from the battery by the network of resistors shown in this figure. You see here 1, 2, 3, 4 and 5 resistance given. This is not a series, this is not a parallel. So in general, when there is a 5 resistance or 6 resistance combination, in most of the cases this will form Wheatstone bridge circuit. Check it. At first you have to make this circuit that is equivalent. Okay, so our problem 1, suppose this point is A, and this point named is B. Suppose this point is named as B, this point is D. Okay, suppose here I am writing D, and this point is C, and this point is C. Now simplify. A to B resistance 1 ohm, A to B resistance 1 ohm, 1 ohm. Now you see B to C, here B to this resistance, that is 2 ohm connected at point C. So B to C resistance 2 ohm, B to C here resistance 2 ohm. Now see A to D, here is this one, A to 2 ohm resistance connected D. So this value is A to D resistance, and here resistance value that is 2 ohm. And D to C that is 4 ohm, D to C 4 ohm, and B to D that is 5, B to D that is 5, and this resistance is the resistance for galvanometer. Okay, and at point A to C there is a connection, that is battery 4 volt. A to C, that is battery is connected, the value is 4 volt. Now see, very simple. At first you check this one is balanced or not. At first you have to make this equivalent circuit. Now check this one is balanced or not. We know for balance condition P by Q that is equal to R by S. Here P by Q that is 1, P1 Q2, so this ratio that is 1 by 2, and R by S, this one R is 2 and S that is 4, so half that is equal to 2 by 4, so this one is also half, so half is equal to half. That is the balance condition, and in balance condition there is no flow of current through this galvanometer. That means here no current is flowing. When here no current is flowing, that means this resistance is ineffective. Okay, this 5 ohm resistance is ineffective. Now very simple, 1 and 2 series, so here equivalent resistance that is 3 ohm. Here 2 and 4, this one is also series, so equivalent resistance here 6 ohm. Now see this one, suppose here the resistance, this one is 3, this one is 3, and here suppose this resistance is 6. Now 3 and 6 are parallel combination, so for parallel combination equivalent resistance R equivalent, that is, you know the formula, R1 R2 divided by R1 plus R2, so R1 3, R2 6 divided by R1 plus R2, that is 9, 3 is a 2, so this one value is 2 ohm. So our equivalent resistance 2 ohm, voltage given 4 volt, voltage that is 4 volt, equivalent resistance 2, so current I is equal to, according to Ohm's law, V equal to Ri, so I equal to V by R, here V 4 and R is 2, so this value is 2 ampere. So the current drawn from this circuit, from the battery, that is 2 ampere. Okay, now see second problem. In second problem, write down first, find out the magnitude of resistance X. That means here you have to find out the unknown resistance. Here unknown resistance is named as X in the circuit when no current is flowing through 5 ohm resistor. So you see here 1 2 3 4 5 combination of resistors. In 4 ohms 4 resistance, and in galvanometer there is another resistance. So this one is also is a Wheatstone bridge. Okay, so first of all you make this circuit like Wheatstone bridge, then you solve it. So our second problem, same, this is a cell 6 volt. Now here you make it like this way, like this way. This 6 volt, this one is X, this one is 18, this one is 18, this one is 2, this value is 6, and this value is 5. Now you have to find out the value of x, and the condition given when no current flowing through 5, no current flowing through 5, I equal to 0, that means the balance condition, and balance condition means P by Q, that is equal to R by S. So write it down here. P, this one is P, x, Q, this one is Q, 18, R, that is 2, and S, that is 6. So x equal to 2 by 6 into 18, that is 6 ohm. So here the value of x, the unknown resistance, is 6 ohm, and we find out this value with the help of this balance condition, that is P by Q equal to R by S. Why balance condition? Here condition given when no current flowing through the 5 ohm, 5 here resistance of galvanometer, and the no current flowing through 5 ohm, that means the galvanometer resistance 0. Galvanometer resistance 0, that implies that the balance condition of Wheatstone bridge. Okay, now problem 3. Same thing, similar to problem 1. Here resistance, all the resistance are named as R. So problem 3, see, first of all make the equivalent. This point is A, so up to this point is named as A, but there is a resistance, so obviously this point will be another name. Suppose this point is named as C. Now see, this point is C, there is a resistance, so this point will be give another name D. And up to this point is B, so this point will also B. Now make an equivalent circuit. Suppose this point is A, this point is D, now this point is C, and this point is B. Now check it. A to D resistance R, A to D resistance R. Now A to C, check it, A to C resistance R, A to C resistance R, this resistance also R. Now check C to B, this one, C to, like this one, C to B resistance R, C to B resistance R. Now D to B resistance R, D to B resistance R. So 4 resistance form a quadrilateral, and there is another resistance, you see, which one, C to D, this one R, C2, this one is the resistance of galvanometer, this one also named as R. So obviously R by R, there is ratio 1, and this one is also R by R, ratio 1. So this one is also balance condition. Balance condition means there is no current flowing through R, so this is ineffective. So this is R by R series, so that is 2R, this R by R series, that is 2R. Now these two are equivalent parallel combination, so equivalent, that is 2R into 2R divided by 2R plus 2R, that is 4R. So R cancel out, this 2 4 cancel out, so equivalent resistance is R. Okay, so solve it. This type of problem is important for your exam. Today I am ending here. In next class we will discuss about the application, the practical application of Wheatstone bridge, that is named as meter bridge. So today I am ending here. Till then, bye bye.